Welcome to my channel. I'm playing with junk again, or today I'm playing with chips. No, not French fries, no potato chips. Silicon chips, computer chips, like this 8008 processor here. Like this 8088, that's the predecessors of our modern PC processors. I also have a 8286, a 386, a 486 and a 586, where they changed their name to Pentium. That means the fifth of the series is it Greek? Is it Latin? I'm not sure. It means 5, so it's in fact the 586. Okay, they call it 8501, but well, it's the next step here. The problem is, if you want to see the chip, that's not the chip, that's the chip package. So if you want to see the chip, you have to open this thing somehow. So with these plastic cases here, there are some tricks with boiling acids and stuff, but I think that's a bit dangerous. So I prefer the ones that already have a window. For example, this EEPROM here. And the reason why it has a window is simply that UV light can get inside. And UV light makes the chips or the surface of the chip slightly conductive by putting some UV photons on the surface, and that makes the stored information, the stored electrical charges, flow away, and that's to erase this chip. And after exposing it to UV light and erasing it, you can reprogram it like any other storage chip. There are data lines, address lines, stuff like that. But to erase it, you have to expose it to UV light. And that's the reason why there's always a sticker here on the top. Mostly the best stickers are those with some metal foil stuff, but only just standard paper stickers will also do the job. So if you see one of those in an appliance, in a device, without a sticker, with an open window, and if you plan to use it again, you should cover that window before it gets erased. Now for the other chips here, like the 286 and his brothers, sisters, sons and daughters, that was also relatively easy to open them. They have a ceramic package, and on the bottom side they had a small metal cover here, which was soldered to the frame here. You can see the solder around here. Oops. Here, that's just standard solder. You had to heat the chip quite well. That's the reason why this one has some stains and is a little bit brownish here around. And then you can just lift that away and you see the chip and the bonding wires and all that stuff, and that worked easily up to the Intel Pentium, which has of course a much bigger chip, as you can see. And then some 1 or 2 generations later, they changed the design of the chips with this heat spreader type here. And that makes it a little bit more complicated to see the actual chip, the die itself, because the die is sandwiched between this PCB board here with all the gold contacts. That's a PCB with many layers, because all these contacts here have to go to the chip, which is about here. And then the top cover, that metal plate here, is soldered to the chip. So the chip is in fact soldered on both sides. One side to this heat spreader, which is made of copper. It's a solid piece, it's relatively heavy. And on the other side, it's soldered to the PCB through some BGA, ball grid array soldering technique. And if you want to open this one, you first have to cut open the silicon glue, because the heat spreader here is also glued down to the PCB with silicon. So the first step is to take a sharp knife and cut all the way around. Then you have to heat up this area here. And the good thing is you only have to heat it up to about 160 degrees, because the solder that is used between the chip and the heat spreader, so that's the chip, I broke it because it was not so easy. The solder that is used here is more or less pure indium, and indium has a melting point of 156 degrees. I think that's the reason why they have chosen it. It's very soft. It melts at low temperature, and well, maybe it bonds better to the silicon chip, while the inside here seems to be gold plated for some reason. Maybe oxidation, because there is a hole. This hole is now filled with thermal paste, but normally this hole is open. You can see that's the thermal paste. And this is used as a vent hole, because when the chip heats up, the air inside this cavity here will expand, and there must be a way for the air to escape, because it would simply lift off this cover, and that's bad for the chip. So I think that's the reason for this hole. If you put thermal paste on the chip, some of it will actually get inside here. So if you're using a conductive thermal paste, you better should not take too much, because if that is filling up this cavity for some reasons, I mean, some people are doing crazy things, filling up everything with thermal grease, that would simply make your CPU useless. Now here is a piece of this solder. I just scraped it away, or I melted it away. And indium is an extremely soft metal, and then I can show you that here. Maybe this wooden toothpick here. Yes, it already leaves an indent. You can see that. Or if I take my screwdriver, just push it a little bit. Yeah, it gets bent. It's a little bit like an old chewing gum. It's not very hard, so hard candy would be harder than this. You can also fold it around, so it's very easy. And that's not tin foil, it's a solid piece of indium. Well, I have some more here. You can also form balls just by rolling that long enough. Yeah, it's soft, it melts at 156 degrees Celsius, of course. And if it is blended with other metals like bismuth or tin, sorry, that was the German word for it, you can even achieve a mixture that melts at 62 degrees, like that one. You can buy this in some novelty shops, or in fact it is much harder, but you can put it on a teaspoon, put it into hot water. It doesn't even need to be boiling water, and it will melt because it melts at 62 degrees Celsius. So that's probably the lowest melting metal in the world. And its main component is indium. Okay, let's take a look on the chip. Oh wait, I have another one. This one is a Opteron 6274. It was broken, and now it's a little bit more broken. So I opened that cover here just by ripping it apart without heating the chips to desolder them. And the chips, two of them, just split between the layers of the chip. So that's the only way to see inside, because if you desolder the chip properly, like I did with this half here, that's the other side, and the only thing you can see is a fine grid of solder balls. On the other side is solder area, so you don't see any structure of the chip itself. So it's a little bit sad, but this one looks better. By the way, this is a 4-core processor, and that's another 4-core processor. And the AMD Opteron 6274 is in fact an 8-core processor. And that's the reason why it has this unusual format here, because they simply put 2 4-core processors into one case, connected them together with this PCB, and that's it. That's the AMD way to make a 8-core processor. First, have a look on that EEPROM. That's the type MBM 27128. That's a 128 kilobyte, or was it kilobit? I think kilobit EEPROM, made in 1985 from Fujitsu, made in Japan. All the good electronics come from Japan, as you know. And here we have the chip with some bonding wires. Let me see if I can get that a little bit more in focus. So that's only a memory chip. You can see the 2 memory arrays, left and right, and some driver circuitry around the chip. So let's see if we can get that a little bit bigger. Well, it's a bit difficult to get these things in focus because I'm filming through my microscope and everything is very shaky. Even if I just move my feet, you see that the picture is shaking. So what you can see here in the center is MBM 27128. That's the type of the chip, which is etched into the chip itself. So let me see, and there is the brand name Fujitsu. You can probably see it. It's a little bit hard because I have a reflection here, but you can see the Fujitsu name here. So that's the row, that's the grid of storage cells. That's some addressing and stuff. I'm not a chip expert, I just admire the beautiful look of everything. That's the bond wires. And that's a bit the funny thing here. Let me see that a little bit small. There is one bond wire connected to this round blob here. It's like a barrel, a tower, a round one, which seems to be glued to the base of the chip. And maybe you can see it from that side. Where is it? Here is it. And there are 3 wires that go to the same pin. So that's probably ground, probably a grounding for the ground plane, the base here. I don't know. Maybe it's something else. If you know it, please write it down in the comments. I'm always happy to learn stuff that I didn't know yet. Okay, let's have a look at the 286. That's the 286 processor. It looks a little bit strange. It looks like it's corroded somehow. Probably it's just dirty because I had it open like this, lying around on my board. The gold, of course, is still very golden. Gold does not corrode at all. But the chip looks a little bit nasty. You don't see a lot of details, and that's not because I'm out of focus. That's just, well, it seems to look like that. Now that's the 386, and even if it's the more modern processor than the 286, the die itself is much smaller. So they probably switched to a new technology, a new density, a couple of nanometers less than before. That looks a little bit better than the 286. Not so much corrosion, or maybe not so much dust. Yes. So I think it's mainly dust. I probably should keep them under a cover of some sort. Let me twist that around. Sometimes we get some interesting color effects. Yes, look at that. We get green, we get purple, all colors of the spectrum. And if we turn it around and the light comes in from different sides, ooh, we get a dark blue, that's nice. Green, so whatever color you want, you just have to turn your chip. Maybe that's the way how color TV works. Oh yeah. So let's jump to the Pentium, or the 586 as I like to call it. This is a much larger die. It's at least 4 times, even 5 times bigger than the 286, and maybe 6 or 7 times bigger than the 386. And here we can play with the colors. You can see the dust. Yes, in this case it's clearly just the dust. Maybe I should clean that before filming. Okay, I just cleaned it. I held it under my water tap and brushed it with that brush here, which looks like a giant, but it's a very small one. And I was very careful not to break these bonding wires here, and yes, it definitely looks better. Let's turn it to another color. I don't like the green. I more like the red colors. That's my preferred one. It's a little bit difficult. It seems that green is the preferred color of this chip. Maybe this has to do with the structure. They are smaller, so they won't produce any red lights. We only get blue and green, as it seems. Well, there's a little bit orange. No, not as colorful as the older chip. Okay, but let's go to a modern one. That one looks nice. So that's the AMD Opteron with its 2x4 cores. So as I said before, this chip here is split between the layers, so that's not the top side and not the bottom side, that's something in between. You can see a pattern of dots here. That's already the dots of the lowest layer that is connected to the PCB. That's the ball grid array, but also some of the layers of the, for example, the cache and all that stuff, the CPU cores. Let me see on the other side. That's the part that is still attached to the heat spreader, the cover of the chip, if you want so. Oh, that's a nice one. Seems that is some array of memory. Maybe it's one of the lower level caches. Maybe it's just some registers, maybe. No, I think it's a little bit big, so must be caches. Let me zoom that in. As I said before, I'm not a chip expert here. I'm only looking for nice patterns and beautiful colors, and it seems that I found a sweet spot right here. Let me see if we find something else, maybe on the second chip. So that's where the chip is broken. This is pure silicon, single crystal silicon. And that's the last chip for today. It's Intel Xeon E5-2643. This one is a relatively modern processor. Still costs a couple of dollars. So that's the chip with the solder side up. That means that is this side that is soldered to the cover, so it's the upper side. And here you see the PCB, so half of the chip is broken away. That's the ball grid array, and you can also see that not every single ball is one pin. There are a lot of pins, a lot of balls here connected together on this PCB. So that's the solder balls a little bit closer. You can see some are connected together. Some seem to be separate individual pins. There are whole rows here of pins. That's probably some ground or power supply. There are lines and lines. So most pins on these chips, about half the pins here, especially on this side, that's the contact side. That's the pins you see when you flip the CPU over. So half of the pins here are for ground and supply power, because chips like this use up to 100 or even 150 watts, and at maybe 1 or 2 volts supply voltage, we're talking about 50, maybe 100 amps. And of course, a CPU socket cannot supply that to only a few pins, or even 1 pin. Okay, so let's see what the chip is looking like. So that's the bottom side of the chip. It's a very dense ball grid array. Here some balls are missing. These here seem to be still there. And if I flip it over, we see the same surface with solder on it, so it's not very interesting here. Well, that's it about chips today. But before you leave, just have a look at this. Thanks for watching.